Everyone thinks the AI race is about GPUs, power, and data centers. But one of the strangest bottlenecks is glass, fiber optic glass. The newest AI data centers do not just need chips that calculate, they need millions of tiny paths for data to move between those chips. A GPU by itself is powerful, but modern AI is trained across racks, rooms, and entire buildings of GPUs working together. Each chip has to send data, receive data, synchronize, wait, and move again. If the network is too slow, the expensive chips spend more time waiting. For short distances, copper cables can still do a lot. But as AI clusters get larger, faster, hotter, and more power hungry, copper becomes harder to scale. Signals degrade, cables get thick, power loss gets expensive, and heat becomes a problem, so the data starts moving as light. An optical transceiver is not a glamorous AI chip. It does not write poems or generate images. But it turns electrical signals into light, sends them through fiber, and turns them back into electrical signals on the other side. If those lanes are full, the GPUs wait. Reports in 2026 show AI data centers consuming fiber optic cable faster than suppliers can make it, with some orders stretching into 2027. TrendForce expects the global AI optical transceiver market to reach about $26 billion in 2026, with component shortages identified as a primary capacity expansion bottleneck. Inside that bottleneck, there is another bottleneck: lasers. High-speed optical modules need tiny laser components to send data as light. For 800G and 6T networks, the supply chain gets more demanding: tighter tolerances, more heat, more testing, and more failures if the design is not right. This is why another video saying NVIDIA is important is not enough. Everybody knows that. The sharper question is what NVIDIA's customer needs after the GPU arrives: power, cooling, memory, storage, and a network fast enough to keep the whole system from choking. For investors, the point is not to buy every company that says optical or AI. The better question is, who controls scarce capacity? Who can scale 800G and 6T? Who benefits if AI clusters keep getting larger? And who is already priced like perfection?